All right, so for 7.2, we're going to get back to the Excel in a minute, but we have some notes that we need to talk about so that we can bridge what we've done with where we're going. So we're going to look at example 2 first. We're going to let f of t equals c, which is the constant function. So any number, okay? We're going to look for the area under the curve, which is what we were doing before. We were using Riemann sums, okay? So let me kind of draw out maybe the graph here before I do it later. Normally I do it later, but I think it'll help here. So we have this constant function. Okay, it's a horizontal line. And we're going to look for the area under it. Okay, so somewhere from here to here, we want all this area underneath it. Okay, here's A, here's B, here's C. We have some length X in between. Okay, so my height for this rectangle is C. And my width, again, it can adjust, would be B minus A. Okay. So an obvious area function would be f of x equals c times x, that length x on the bottom. So let's put it into integral form so you can kind of start looking at what that looks like. Okay, so the integral from a to b, the lower one goes on the bottom, of c dt is equal to the function evaluated at b minus the function evaluated at a. Okay, in order to do that for this function, we would plug it into right here. So we get c times b minus c times a. Okay, so we did do this the other day. Okay, we did this when we had the constant function of 60. So we're going 60 miles per hour. So if we did that with we went from 0.5, we went from half an hour to 3 hours at 60 miles an hour. Okay, we would have evaluated at f at 3 minus f at 0.5. Okay, so we're going to take 60 times 3 minus 60 times 0.5. And we ended up with 180 minus 30, which gives me 150. And I'm pretty sure that was the answer we got the other day. Okay, so this is where we're headed for 7.3. Okay, so let's do another example. Example 3. We're going to go up one notch. We're going to let f of t equal c times t, our linear function. Okay, so this time, here's my graph. Oops, let me kind of color that in a different color. Let's put that in blue. So here's my function. F of t equals ct. And we're looking for that area underneath. Here's A, Here's B, here's my area. This time I have 0 at the end. Okay, so we're looking for the area under the curve. From 0 to B, where 0 is less than or equal to X is less than or equal to B. Okay, so this time we have a triangle of sorts. Okay, so my height here, right here, is C, some constant C times B. So C times B. And my base is just B. Okay, so that's going to come in handy here in a minute. Don't forget that the triangle area formula is 1/2 base times height. Okay, so let's put this in the integral formula. So again, we get used to it. A to B, CT dt. So again, the dt here is just part of the integral piece. The CT is the actual function. Okay, we're still going to have f of B minus f of A equals, okay, so we're going to have CB squared over 2. So we're going to go back to this, CB times B, here's my over 2, minus CA squared over 2, which could be simplified to C times B squared minus A squared. Look at that. That deals with the triangle over 2. Okay. One huge clarification that we're going to do now is instead of right-hand sums, we will more accurately use midpoint sums. So we're going to change our Excel workbook here in a minute. Okay, so the next one that we're going to look at, we're going to use Excel to do because we can't really make nice little figures like we did for the first one. We made a rectangle, then we made a triangle, then it just gets too complicated. So I'm going to switch to the textbook to make a couple comments, and then we'll switch to Excel. Let's see here. All right. Okay. I did those two. Okay. So here's what we're going to do now for the midpoint sums. So before we were doing the right-hand sums. So we were bringing it from here over to the left. And now we're going to do it from the middle. Okay. So it says for this specific figure, we go from having a 7.5 to a 5.25, which is much more accurate. Okay. It's going to just change one thing in our Excel workbook. Okay. All right. So I'm not going to do example 5 on Excel. I'm going to do example 6. Again, my Excel workbook will match the one we did last time. Unlike, it will not look identical to this one. It'll look pretty close to this one, but not quite. Okay, so we're going to do the area function f of t equals 6t squared on Excel. So let me switch to that. Okay, so again, we're doing f of t equals 6t squared. So a very easy function, okay? We're gonna do the same labels as before. A is the left end, B is the right end. Too many parentheses there. We're gonna get the number of intervals and the delta x, okay? So the left end here, they tell you in the book to go from 1 to 10. And the number of intervals, most of the time we're going to use 100, and this time we're going to use 100. Okay, so again, this is a very specific formula. We're going to do B4 minus B3 divided by B5. Okay, make sure you don't divide it by the number of intervals in terms of the number. Make sure it's divided by the cell reference. Okay, so then we're going to do n. This time I like to rewrite it as mid x sub n to remind myself I need to change my formula. F of x sub n or f of x, however you want to put it in there. Or f of mid x sub n, however. The area of the rectangle and the sum of the area. So I only change one title, and that's the only place I'm going to change it. So again, n's going to start at 1 and then go on. So I did see one group in the classwork start at 0. 0 is not where you start because you can't have an interval that starts at, or that goes from 0. It always starts at 1. So make sure you start it at 1. Causes big issues when you're doing this. All right, so mid x sub n is going to have an extra piece in it. It's going to start in the same location where you have that $B, $3, plus before we did A9 times. Now we need A9 in parentheses minus 0.5. Okay, there's a couple different ways I've seen it in the textbook. The best way to do it is just to subtract half of that rectangle off. So we want half the rectangle, we want to be in the middle of it, times your delta x, $B, $6. So again, the only thing I want to change is this interval, and I need to do A9 minus 0.5. Okay, quick fill that one down. My function here is 6 times, again, the column before, B9 squared. Quick fill that down. Our area of our rectangle is referring to the row or the column before times the width of that interval, which is delta x, $B, $6. The sum of the area is sum, parentheses. We are taking D, $9, holding that one still to D9. Quick filling that down. Then I need to pull the area up. You can put this anywhere up in the upper quadrants here, in the upper cells. Equals offset. Again, you can actually click on these if you want. You want the title from the column that we're using. We want the number of intervals, so we need that cell reference, not a number. We want the cell reference in case we change it. And then we don't want to go anywhere left or right, so we put 0 in. So we get 1,997.964. Okay. So along with this, in the book, they have a graph that goes along. So every semester I started just showing the graph rather than confusing students by creating the graph, because you won't have to create the graph. So let's look at the book and the graph that came in the book. Okay, so notice that in the book, it doesn't show you the answer here. It shows you all the formulas that this workbook used. Notice that their interval width is not the same as mine. So we're going to, again, follow the same thing that I got. So we never know what the answer is from the textbook, okay? They want you to look at this graph, which doesn't apparently get much larger, but I can make it a little bit larger, I believe, here. So what happens here is we get, instead of 6t squared, you finally, you graph the summed area piece and then do a line of best fit, and you have to play around till you get the one that works. But you find out that the antiderivative ends up being c times t cubed divided by 3, sorry. So you don't have to worry about that part, but we're kind of building up and seeing, hey, when we had a constant function, when we find the antiderivative, it's c to the x, or c times x. When we do the linear function, you get c times t, and then you get the antiderivative, and it's cb squared over 2. And then we got this one. So we're going to do one more in Excel to make sure that we know how to do this. We do have another day of doing Excel workbooks. It's the last day. So we're going to do 6x cubed. So look, we're not going to find the exact answer to match it to the textbook, but we'll be fine. So we're going to do one more. We're going to do f of